Okay, so we're looking at perfect squares, perfect cubes, and their roots. You've already talked about square roots. You've talked about perfect squares. I think in grade 8, that part of the curriculum is to know the first 10 perfect squares, right? So 1, 4, 9, 16, etc. So we'll go through that in a sec. And so this is kind of review. All right, we're going to try to do some of this without a calculator. And so we'll use our knowledge of factorization from last week. Prime factoring helps a lot in terms of without a calculator. There might be situations, say on the first test, where we give you part A, no calculator, part B with a calculator. So you have to, part of being in this dash 10C and then dash 1, dash 2 sort of stream of classes is to have some mental math skills, right, without a calculator. So perfect squares. What do you do? How do you know something's a perfect square? Have to try to kind of come up with a definition here.
Oh, I don't know an exact definition, but 2 times 2. When
Yes.
it multiplies by itself, then it's a perfect square.
Right. So when you multiply a number by itself, you get a perfect square. Yeah. Oops, just a sec here. So the result of multiplying a number by itself. Okay? Something like that. We're not going to ask for a definition on the test per se, but you have to be able to recognize it. Okay? Square root. So basically it's the opposite of squaring a number, right? So it is, so what's the easiest way? The number, okay, so square root of 9 is 3. So 3 is the number that is, so it's not the result, it's the number that is multiplied by itself to get the perfect square. I know my writing's not great on this tablet, but it's better than using the board because, as I mentioned to you before, the board doesn't read anything properly. Okay, so this is the number that is multiplied by itself to get the perfect square. So if we've got 9, the square root is 3. You can take the square root of numbers and have to round it because it's not a perfect square, right? And you get a decimal. So you can get close to that. And really that's what we're going to talk about tomorrow, estimating perfect squares. And your calculator will do those estimates. And then you would round it. The biggest thing that you're learning about perfect squares this week is how to simplify. And so to simplify, we don't get any decimals, we don't use our calculator per se, but you get that radicand, which is the number underneath the radical. So this here, whatever number's there is called the radicand, as small as possible. Just like with a fraction, you always want to get the denominator as small as possible. That's what the biggest thing that you're going to learn this week, and most important thing. So some numbers have a square root, but there are some numbers that for which you cannot take the square root. What numbers can you not take a square root of? Anyone remember? Right, you can get an approximation, so you can still kind of take it, but it's not, you can't get the exact value of it. Root 2 is the exact value. But what's an example that you can't even get a square root of? You put it in your calculator, it will give you an error, is a negative number. Okay, so negatives, negative numbers. And if you remember, the reason being is the definition of getting a perfect square is taking a number and multiplying it by itself. Well, if you were to take negative 3 and multiply it by itself, you would get 9. You wouldn't get negative 9. There's no way of finding two numbers that are exactly the same when you multiply together to give you a negative, right? So you can't go backwards. So, okay, so then here, how many square roots does a positive number have? It just has 1. We'll go through situations where there's kind of 2 in a way, but where they start from. So next step here, when you're dealing with an equation that has x squared equals 9, then there's 2 possible values of x that work there. Yeah, 3, yeah, got to use your, put up your hand, okay? So 3 and negative 3. Some people will think that, oh, okay, root of 9 is 3 or negative 3. It's not. That is it. If nothing is out front, it means it's a positive, right? Yes, negative 3 squared is 9, but this is considered an operation. It's not working backwards to this. So then for x squared equals 36, it would be 6 and negative 6. Okay, so here's the summary. So if x is the square of r, then r is the square root of x. So kind of seems confusing, but let's take a look. So now if we have r squared equals x, then r equals the root of x. And root of x exists only if, obviously, the x is positive or 0. Root of 0 is 0. Now this here always denotes a positive square root. So as I said, it's understood to be a positive. We never give a negative, okay, unless you're solving an equation. And that's where you will get the 2 solutions. So only when you are solving the equation do you get 2. Otherwise, the root of a number only has 1 value. Okay, so you write in the answers to the next ones. Don't use a calculator. Use your memory. Root of 9, root of 16, and what do you think root of 49 over 64 is? So just write them in on your paper. Okay, so we've already done root of 9 is 3. Root of 16, hands up. At the very, very back. 4. Good. Okay, root of the fraction in red. Good. Okay, so you can treat this as root of 49 over root of 64, right? So you're doing each one separately.
Please excuse the interruption. Can we get grade 12, surname A, B, and C, down to the stage area via the Gazette hallway? Stage area for photos, grade 12, surnames A, B, C. Thank you.
Okay, so what if we are asked to evaluate a number that is not a perfect square that we remember, right? So maybe you know all the perfect squares up to 100, but nothing past that. You should have those memorized. But bigger numbers, 576, maybe you know it, but maybe you don't. So let's go through the process that what you would do if you didn't have a calculator. And so we're going to keep our calculators away for now. And we give you a hint on the left here. Write the number as a product of its prime factors. Group the factors in pairs. Rearrange the factors into 2 equal groups. So we did prime factoring last week. So start with 576. Okay. And if you're, yeah, you could try to find big numbers, but just start with 2. If it's an even number, make it easier on yourself. So now divide this 576 by 2. What do you get? Well, 2 goes into 5 twice. Carry the 1, so that's 8, and 1 is 8. 288. even number again. 2 divides into 288, 144. Now you might remember 144 is a perfect square. You might go 12 and 12, or I'll do complete prime factorization. You wouldn't have to do complete if you can see it, but that'll be 2 and 72, 2 and 36. Gonna have to do 36 over here. 2 and 8. Oops. 2 and 18. 2 and 9, 3 and 3. I'm just doing all of it, even though I could see what it would be. 144 is 12 squared, just so that I can follow these steps on the left. So now I'm going to group the factors in pairs. So there are 2 2s, 2 2s, 2 2s, lots of 2 2s, 2 3s, okay? And rearrange the factors into 2 equal groups. And so that means I take one of each of these. So root 576 is going to be 2 from that group times 2 from this group times 2 from that group times 3 from that one. And 4 times 6 is 24. Which, as I said, you might already remember that the root of 576 is 24. Kind of a fairly common, larger perfect square. But that's the process if you had to show all your work for it. Yeah. Okay. So, same process for the next ones. I want you to do question 2A and B. Okay, without a calculator. Maybe you can guess and check, but try to have a process like I did there. Now, in 2025, 2 doesn't go into that. But anytime a number ends in 0 or 5, you know 5 does. So start by dividing by 5. The hint in B, even number, so I divide by 2. Even number, divide by 2. 441, it's not even. So then try 3. Remember what we talked about, the trick for 3 is if the digits add up to a multiple of 3, then it's divisible by 3. So 4 plus 4 plus 1 is 9. So I know 3 goes into that. So 47, maybe I don't know that either, but add them up. 1 plus 4 plus 7 is 12. So I know it's divisible by 3. Okay, so continue on from there. Okay, so square root of 1,764 is 42. If you have, this is going to lead into what we're doing this week.
Grade 10s, surnames D, E, F. Grade 10s, surnames D, E, F. Thank you.
Any of you guys still need to get your photo done?
Are these for retakes?
No, these are the first ones. Yeah, you did them. Okay, so no. If you didn't come in for Passport for Success, you go. So here, say you had another factor. So say this was 7 times 14. Then you would do 14 is 2 times 7. And that you'd have an extra 2 left over, right? That wouldn't be a matchup. That would be a non-perfect square then. And so when we simplify it, we would get 42 outside, but then root 2 would be left underneath the radical sign. So that's what we're doing later this week. But we're getting into the practice of doing these. Obviously, if it doesn't ask you to show work, then you don't have to show all of those steps. But if it's in on a test as a written response, then and it says the word determine. So that's going to be an important word for you guys because in grade 10, you haven't really used it too much. So in terms of being asked what to do in a question, if I say determine the answer, that means show some work for it. Okay? If I just say what is the answer or state the answer, I don't care about the work. So that word determine is going to be really important, particularly when you get to grade 12 and are writing the diploma exam, because that's the word they use. Sometimes we might say, you know, when you're solving an equation, and I know when I first started teaching, I taught in Ontario, and we would just say, find the value of X. Well, really, we here in Alberta, we use the word determine, because find doesn't mean you have to show work, but determine means we want to show the work. Okay, so find would be just give me the answer. And so the wording is really important. So just be aware of that. Okay, turn over to the next side. An application question, which very common type of application question. Says a square has an area of 324 centimeters squared. So if I were to draw, that's not a great square, but it's close enough. Remember, the sides of a square are all equal in length. Okay, and the area is 324. Okay, what's the formula for area of a rectangle? Who can tell me? Hands up. Yep. Length times width. This is a special kind of rectangle. Okay, what do we know about the length and the width when we're looking at a square? Hand up, but they're the same or equal. Yeah. So here, this means that this could be L and this could be L. So basically, L squared equals 324, the area. So the opposite of squaring is square rooting. Now in this equation, we said on the last page we could have negatives. Can you have a negative as a length? No. So we're just going to show this as the root of 324. Okay, so it says the word determine. So we've shown that work. And now take 324 and do exactly what you were doing in the last questions. So prime factorization. And once I hit 81, I know 81. So in this case, I might do 81 as 9 times 9 and leave it there, because it didn't say I had to use prime factorization, and I've got my two pairs, right? And so now I know that the length, if you did prime factorization, yeah. So I'll show you the difference. I'm stopping there so that I go 2 times 9 is 18. And then it is a length, so I use centimeters. If you wanted to go further here and do prime factorization, then this is what it would look like. 9 times 9, 3 times 3, 3 times 3. And I go, oops, want to do that in red, just a sec. So then it would be 2 times 3 times 3, which is 18. So either way, you get 18. Okay, need the units at the end. Don't keep the centimeters in your work. Just keep it at the end. Or put it in at the end. Okay. So, perfect cubes. So that is, if we take a look back at what we said for the perfect squares, we said the result of multiplying a number by itself. Perfect cubes is kind of similar, except how many times do we multiply? 3. 3 dimensions. A cube is 3 dimensions. So the result of multiplying a number by itself 3 times. That got a little messy. Oh, sorry. Okay. Cube root, what did we say in the original? We said the number that is multiplied by itself to get the perfect square. So this would be the number that, are you okay over there? It's got a delay, right? So I just couldn't spell that right. Which I can't see when I'm doing it because it's so slow. Okay, so you can see actually from a diagram of a cube. Okay, so a cube means all the length, width, and height are all the same. If we went 6 times, so that would be 6 there. This would be 6 here, and then this depth would be 6. So if you think about 6 cubed, again, without a calculator, well, in your head, 6 times 6 times 6 is 36 times 6. And if you do that in your head, you get 216. Because 3 times 6 is 180. 6 times 6 is 36. Figuring that out in your head, right? So if you are given a cube and you want to find the cubed root, the volume of a cube, and you want to find the cubed root, that would be the side length. Okay, so just in summary here, if x is the cube of r, then r is the cube root of x. So that little 3, so instead of, so this we know is a square root. We don't have to put a little 2 there. Square roots are so common, we don't have to put a little 2. But any other root, we have to identify what it is. So we have to put a little 3. It's the size of an exponent, but it's just at the top left-hand corner. Cubed root, we could do 4th root, 5th root, etc. The cube root of a positive is positive. Now take a look here. You can take the cubed root of a negative. Because remember, if I have negative 3 times negative 3 times negative 3, so I've got 3 factors of exactly the same number, I get negative 27. So I can take the root of a cubed root of a negative. Not square root of a negative, but the cubed root of a negative. Okay? So without a calculator, determine the cubed roots of the following. First ones, hopefully you know, and then this is just a fraction. So 27 is 3 times 3 times 3, right? So that's a perfect cube that you're going to need to know off by heart. Basically, the first 5 whole numbers cubed, got to know them. So 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. Okay, so for sure those ones without a calculator. So cube root of 8 is 2, cube root of 125 is 5. Okay. So now when we do big numbers that you're not sure about, we're going to group them in 3s, not 2s. So if I take 2,744, I'm actually just going to make this thinner to try to fit it in. So I know it's even, so I'm going to go 2, goes into that 1, 3, 7, 2. I'm going to keep going by 2s. So it makes it a little bit easier. Okay, so you keep thinking about that. Keep dividing by 2s till you can't. Can't, right? So this one, 343. Well, is that divisible by 3? No. So then 4 is not, because it's not even. 5 it's not. 6 is not, needs to be even. Try 7. So let's try 7 in that. 7 goes into 34. 4 times 28. Carry the 6. Goes in 49 times. And then what's nice is 49 is 7 times 7. So now you can see those groupings of 3 2s, 3 7s. So this is equal to 2 times 7, which is 14. Okay, so that means 14 cubed is 2,744. But you have to really pay attention to that little 3. So some of being good at math is attention to detail. Yep.
So what if you don't have like
Then it would stay underneath the radical sign. So we haven't done those yet. That's what I was saying, like tomorrow or the next day. We might have a case where, oh, there's going to be another number left out, and that will then be left under the radical. Yeah, it's a leftover. Yeah. Okay. So again, try these ones on your own. Okay, so those are done. I did in B, I started with 5 as my first divisor just because I saw it ended in 5. So I found that easier. Question? Yep, you can come up and sign out there. So once you've done that, turn over the page and there's an application with a cube. So applications typically for cube roots are with roots, 3 dimensions, and for square roots are with squares. That makes sense with the words. So now we have the volume given to us. And remember the volume of prism. So a cube is a special prism, right? It just has all the dimensions the same. But the volume of a prism is length times width times height. And if they're all the same, because this is the same as this, is the same as this, all of those, then the volume is the length cubed. I use a written L just so that it doesn't look like a 1. And so L is the cube root of 1,331. Again, it does say determine, so we do want to show that factorization. If it didn't, then I would for sure show this step on the left, but then you could just find the cubed root. So say the volume was 27, I would show that the length is the cubed root of 27, and then I would just say that the length is 3 if it didn't say determine. But it does. So I'm going to check here. Now, 1,331. So 4 and 4 is 8. So it's not even. 3 doesn't go into it. 5 doesn't go into it. So I'm going to try 7. And that goes in once with 6. No, 7 doesn't work, does it? So what about 11? Because then 8 needs to be even. 9, same deal as 3, or similar. 10 doesn't, try 11. So 11 goes in once, remainder of 2. 11 goes into 23 twice, remainder of 1. There you go. And then 121, hopefully you remember, that's 11 times 11. So now the length here is 11 centimeters. Question there? Yep, go sign out, please. All right, and then question 8, it says, specifically says, use prime factorization to determine if 2,916 is a perfect square, perfect cube, or neither. So if there's an extra
Grade 12,
factor,
surnames D, E, and F. Grade 12, surname D, E, and F. Thank you.
if there's an extra factor that doesn't group in 2s or 3s, listening please. If it doesn't group in 2s or 3s, then it's not a perfect square or perfect cube. So prime factorization, I'm going to start with 2s. Now I'm going to have to go to 3s, right? And right now, can you tell that it's not a perfect cube? Just from stopping here, I'm not finished. How do I know that it's not a perfect cube? Right, because I only have 2 2s so far, and then these aren't even numbers. I'm never going to suddenly get a 2 back, right, as a factor. So I know right now it's not going to be a perfect cube. I have to finish showing my work though, because I still need to see if it's a perfect square. So 3 goes into that, 81. 81, well, 81 is 9 times 9. It does say prime factorization, so I do have to keep going here for sure and showing all of them. You could do 3 and 27 or 9 and 9 and then go from there. And now I can group those, these, and these. There's nothing extra left. So I know it is, in this case, a perfect square. What is it equal to? So it is going to be 2 times, so the prime factorization, if I do it here, is 2 squared times 3 to the 6, right? And yeah, so it doesn't say what is it, and it doesn't say to take the square root, it just asks what is it. So it is a perfect square using prime factorization. Okay, so that's the lesson. There's practice, just like Friday. Not a lot. The rest is, if you take a look at the timeline, Tuesday, it's in the textbook. Okay, we haven't got our textbooks yet, but the textbook is posted in D2L, so you can do that. If you've done that, or if you don't have access to D2L, most of you should, because I've entered you into the course, but if you haven't downloaded it onto your phone, do that, okay? What's the app called? Brightspace, I think, yeah. So you can do that now, while you...
Grade 10, surname G-H-I.
I'm gonna shut the video off here, I forgot.